Alright, this problem says find the p-value for two-tailed test with a standardized test statistic of z star equals negative 1.71. Decide whether you would reject HO if the level of significance was 0.05. Now there are two ways to do this problem. One of the ways is same as I had done in the previous problem. That would be marking off the boundaries of the tails, seeing where the rejection regions are, and then getting a ZC for those boundaries and determining whether the Z star is going to be in the rejection region or not. That is the method I had used last time. There's a second method that you need to be aware of, which we'll do soon. But let's say, just for now, you try it the way that I had done it last time. That would be marking off those rejection regions, finding the ZC cutoffs for those regions, and then looking at your Z star and deciding whether the Z star is in the rejection region or not. I'll give you a few moments to try that, and then I'll show you the second method that you have to be aware of here. Alright, so one of the things that we looked at last time was finding a level of confidence from alpha. So they tell us here that alpha is 0.05, and we have the formula that confidence level will be 1 minus alpha. We'll have C equals 1 minus 0.05, so C equals 0.95. When we make our two-tailed test, we want 95% of the area in the middle, which means our tails are only going to have 0.025 each in them. And there's our picture. Now, we can go to either the Z table, like the standard normal table, or we can go to the T table to find these cutoff boundaries. So if you do it from the T table, this is a common level of confidence. It's right here. But if you know the alpha of two tails, you can also find that there. Now, because our problem involves Z, we're not using a degree of freedom. Okay, we don't really need the T table, but we can use the T table if we go all the way down to the bottom. Whenever we're doing Z, go to the very last row. Degrees of freedom are infinity. And so we're looking for 1.96 as our ZC. We're going to mark off the boundary, 1.96, that's positive ZC, and negative 1.96 is negative ZC. And now we can see whether our test statistic falls in the rejection regions or not. It is not as negative as the negative 1.96. That means it's actually going to be located here. Within the safe region for the null, which means that we would not reject the null. We call that fail to reject the null HO. Alright, now, I mentioned that there was another way that you want to be able to judge this test as well, and that is by finding a p-value. So a p-value is simply the area that is farther away from center than the Z star is. Now, what do I mean by that? I mean that if you were to let that star be a boundary itself, and then you were to find the area of the tail that it creates, I mean all the area to the left of it, that is sort of the p-value. So it's like a tail, but it's not the tail of the rejection region. It's a tail created by your own test statistic. However, one thing you got to know about a two-tailed test is it has to be symmetrical. So there has to be an equal and opposite tail on the right side as well. And that area is also part of the p-value. So the p-value for a two-tailed test includes both of those yellow areas. All right, so I'll write it here. P-value is the combination of the yellow over here with the yellow over here, but just keep in mind that it does extend all the way out from where that star is. So how do we find that? Well, there's a couple of methods you could use. You could look up the Z star that you found and find out how much area is to the left of it. We've got many methods for that. We could do it on the tables. We could do it on calculator. We could do it with StatTrak. So I'll just do it with StatTrak here. We'll go to just the normal distribution because we're using Z. I'll plug in that Z that I got, negative 1.71. That was my Z star. I need to know how much area is to the left of it. Hit calculate. So 0.044. But keep in mind that is only one side of the p-value. So this yellow here is 0.044. So we have 0.044 on the left, but we also would have 0.044 on the right as well. The p-value will be the combination of those two things. So that's the thing. Our p-value then for a two-tailed test is going to be 2 times the area in the tail of the Z star, but that is of course for a two-tailed test. If you don't have two-tailed tests, you don't have to double the area. Alright, so what's it going to be? 0.088. And now you can make the decision about whether to reject or not based on the p-value and the alpha. So how do you do it? You say, since p is greater than alpha, we fail to reject HO. And when the p-value is less than alpha, we reject.